So, good evening, everyone. Today, we will be discussing about pulp and paper industry. So, it is very important industry in today's generation. Like we use lot of papers, so there is a huge production of paper in this all over the world, right? So, a lot of chemical operations are required. Also, various chemicals are used to treat the wood to make it paper. So we will discuss. Okay. So the first is pulp and paper industry is very large and it is a growing portion of the world's economy. It contributes a lot in the world's economy because everywhere we use the papers, right? Papers, newspapers, boxes, and other forms of paper. So there is huge economy involved in the pulp and paper industry. Pulp and paper production has increased globally and will continue to increase in near future also because there is always a need of pulp. There is always a need of paper. Sometimes we need lot of different qualities of paper, right? Uh, Somewhere there is a very uh, rough paper, we can have hard paper. Somewhere we need the flexible, like some kind of flexibility in the paper, white color paper. Something sometimes we also see some yellowish color, some old look like paper. So this kind of varieties of paper, it all overall depends on the processing of the pulp and from their paper making process. Okay, so it has to be increased in near future also for overall consumption. The pulp and paper industry, they makes the pulp. There is separate section for making the wood uh, digested to make it a pulp. From there, paper production and other cellulose based product will be produced as a byproduct. Now, paper is a thin material. Paper is a thin material that is produced by pressing together moist fibers of cellulose pulp, that is we are getting from the pulp plant, which is obtained from wood, rags, grasses. We can use depending on the type of wood or this cellulosic material that we are using. There will be selection of different pulping process. Okay, we will discuss in subsequent uh, slides. So, and then the moist fibers, they will be hard pressing and then drying them into flexible sheets. Sometimes synthetic materials are also used to impart some special qualities to the finished product according to our requirement, right? Pulp is nothing but lignocellulosic fibrous material that is prepared chemically or mechanically, separating the cellulose fibers from the wood fiber crops, or sometimes recycled paper or waste paper we can also use. The pulp and paper sector is one of the most energy extensive industry globally. So while operating the pulp and paper industry, we need to take care that how much energy we are saving overall, because it itself a very energy intensive process. It is fourth largest energy user and it consumes 15% of the total energy, industrial energy used. So you can see that how much energy intensive process it is. So this is one, you can say this is a disadvantage. So we can have other arrangements if possible to reduce the energy consumption uh, by energy consumption in other way if it is possible. In the traditional pulp and paper industry, 1 ton of paper it generates around 950 kg of CO2 equivalent greenhouse gas on average and accounts for 5.7 percentage of world's final industrial energy consumption and 9% of the manufacturing sector's greenhouse gas emission. So there is lot of you can say sources of pollution. This PPI pulp and paper industry it also uh, pulp and paper industry it is also a source of pollution. There will be various kind of pollution. One is air pollution because of there is lot of CO2 emission. There will be water pollution as well because there will be chemical pulping process where we use generally lot of chemical. Also in the bleaching of the pulps, there is also different chemicals are used. So these are the sources of pollution, environmental pollution. Energy cost is about 1/3 of the total manufacturing cost. So you can see that how much cost is being we are involving for energy consumption. It's around 1/3 of the total manufacturing cost of the thermochemical pulping. So thermochemical pulping, this is a type of pulping we will discuss. Next is pulp mills. They separate the fibers of wood and they form from the other materials such as rags or waste paper or recycled paper, straws, in order to create pulp. Pulp is digested form of that wood, digested in the presence of some cooking liquor. So we will discuss what is cooking liquor and how the operation is being performed in a digester, high pressure condition. And some temperature, obviously that pressure temperature is a optimized parameter. Paper mills primarily are engaged in manufacturing paper from the wood pulp and the fiber pulps also, and they may also manufacture from the converted paper products. Now this wood, it is composed of cellulose, lignin, hemicellulose and some extractive. There might be fats, resins, pectins and uh, this can be extracted at the end. The fiber from nearly any plant or tree can be used for paper making. However, the main uh, concern is the strength and the quality of the fiber, and other factors can make complicate the pulping process. That depends on the kind of trees you are using. You are using uh, soft wood or hard wood. So depending on that, the strength and quality of the fiber will be different. In general, soft woods In general, soft woods they yield very long and strong fibers that impart a very good strength to the paper and are used for making boxes or packaging purposes. Whereas hardwoods, on the other hand, they generally have shorter fibers and therefore they produce a weaker paper. But one that is smoother, there will be more that will be more smoother, more opaque, and better suited for printing purpose. So depending on the ultimate use of the paper, in which form you are going to use, the raw material selection should be done precisely. And also the associated treatment process will be chosen accordingly. Both softwoods and hardwoods are used for paper making and are sometimes mixed also. They provide both strength and printability to the finished product. Now we see the process outline for paper making. The overall process that we are going to discuss in the next few slides. First section is raw material preparation. So what is the raw material here? Different kinds of woods, rags, grasses, like that. So those are debarked, cleaned, washed, and these are chopped into certain reduced size. Obviously, water is being used, so there will be production of wastewater. Now the chopped, reduced size um, raw material or wood material, they will be sent into the next unit, that is the pulping section. In the pulping section, there will be mechanical and chemical separation of the wood fibers from the other impurities. Right? So there we will be using lot of chemicals and also a lot of water. Now the mixture of mixture of dissolved wood fibers into water, that mixture will be sent for pulp washing and bleaching section. That would remove the residual lignin. Also there is use of water and wastewater will be collected at the end. Then stock preparation. Stock preparation is primarily for making the desired quality of paper, and the paper machines are used, some additives are used to make a finished paper as our ultimate product, and there will be lot of wastewater generation. So you can see from overall the paper manufacturing plant, there is a high source of wastewater generation. So we need to take care of this wastewater treatment properly so that it doesn't contaminate environment. Now we will discuss briefly what are the raw materials and uh, specifically we use for paper making. So there are two types of raw materials for paper making, namely wood and non-wood portions. Wood may be eucalyptus, non-wood banana leaves, bamboo leaves, leaves means that stem kind of thing. Of this type of wood and non-woody portion, the pulp and paper industry uses the wood as a raw material. Each type of wood produces different types of pulp. So that's why I already told that depending on the finished product, we need to carefully choose what kind of wood you are using for the process. You see from this variation, in the hardwood, the cellulose, hemicellulose, lignin is different from the softwood condition. Hardwood we have cellulose of 45%, whereas in the softwood it is 42. Hemicellulose hardwood 30%, softwood 28%. Lignin hardwood 20%, softwood is 27%. Extractive hardwood is having 5%, softwood is having 3%. Now in the raw material, definitely we are having woody portion, that is the main raw material. Also there is requirement of the cooking liquor. This is another important component for pulp making, and these are divided into three categories. It is very important, you need to understand and note it carefully that what kind of cooking liquors are used in the pulp making process. Okay, so first one is white liquor. This is the main cooking chemical that consists of caustic soda, NaOH, aqueous NaOH, sodium sulfite, Na2H, Na2S, and sodium carbonate, Na2CO3. Okay, white liquor has NaOH, Na2S, and Na2CO3. Black liquor, which is a washing liquid containing lignin and some dissolved chemical that will be collected from the this black liquor is collected from the bottom of the digester. This is nothing but a washing liquid that containing lignin and dissolved chemicals and is used to meet the needs for cooking fluid in the cooking process. So there this black liquor production and its uses in the pulp making process we will be discussing in the flow sheet. And white chemicals, they contain the bleaching agent chlorine dioxide for increasing the whiteness of the pulp. That is at the end. So pulping process, wood is the raw material and it is mostly composed of cellulosic fibers. Cellulosic fiber, they gives the tensile strength. Tensile strength means that you are holding these two and there will be tensile strength creating in this direction. And cellulosic fiber as well as lignin will be there, lignin matrix. It provides the compressive strength this way. Tensile strength in this way and compressive strength is this way. The force is acting. Cellulose is a linear poly-beta glucose and pure cellulose is white in color. Cellulose is the fibers of primary interest in paper making. Comprises of about 50% of the wood by oven dry if we are considering oven dry weight. So 50% of the wood has cellulose and that is of the primary interest for paper making. Lignin is also present. It is a very complex structure, aromatic in nature, highly cross-linked and causes paper to get yellow on the aging due to radical oxidation process over the period. Lignin, it cements the wood fibers together. It is the purpose of lignin. Now, in the pulping process, it mainly aimed to remove as much as possible the lignin content without sacrificing the fiber strength, thereby freeing the fibers and removing the impurities that cause the discoloration and possible future disintegration of the paper, we need to remove those impurities, and also the main target is to remove the lignin content. Now, hemicellulose is also a component of the wood because we already discussed about cellulose, lignin. Now, the hemicellulose content is similar to cellulose in composition as well as function. It plays an important role to fiber bonding in the paper making. Several extractives, waxes, oleoresins, these are contained in wood but they do not contribute to its strength properties. So these can be considered as impurities and these should be removed by pulping process. I hope it is clear that pulp is nothing but digested form of the wood. Wood, there is cellulose, hemicellulose, lignin. Cellulose, hemicellulose are desired content. Lignin is not a desired content. Lignin should be dissolved in the cooking liquor and it should be taken out of the thing. And those are that pulp is further processed, bleaching and other activities. Continuing to the pulping process, pulping can be different types. One, it be mechanical pulping, chemical pulping, and chemi-mechanical pulping. This is a combination of two processes. Mechanical pulping, this method consists of in grinding the raw material against any abrasive surface to defiber the raw material, more generally the soft wood, without any lignin dissolution. So without affecting the lignin, we are only trying to defiber the raw material. So the raw material are grinded in the mechanical pulping without any lignin dissolution. Chemical pulping also mostly adapted chemically, industrially, that is the craft pulping. Obviously, there are other chemical pulpings are present. So this chemical pulping, in this method, it separates the fiber from the raw material by making the soluble all of the non-cellulosic component in a cooking liquor. at a certain high pressure and temperature condition. This pulping gives better quality, but it already I mentioned this creates lot of pollution. Wastewater creation also there will be air pollution. Chemi-mechanical pulping, this method involves a chemical pretreatment of the raw material. Before that, uh, this method involves a chemical pretreatment and then it is sent to the mechanical treatment to liberate the fiber. So three methods of pulping is available, but mostly chemical pulping is adopted. You need to take care of certain important factors for pulp. So the first factor is moisture content of the pulp. It is very important in the point of view of storage, its transportation and handling point of view. Moisture content of the pulp. Also the dirt content of the pulp, particularly of recycled pulp, is important for its suitability to make fine paper. Fiber length of pulp is also one of the most important parameter of pulp. So we already discussed that hardwood, softwood, for them the fiber length is different, and that also is a very important parameter for pulp making. Fines content and additional measures of pulp particle size is percentage of the fines. Now the kappa number. It is important. Kappa number of the pulp is determination of the relative hardness, bleachability, or the degree of delignification of the pulp. How much lignin content is present in the pulp, that is being denoted by kappa number. Permanganate number, that is K number, it is a chemical test performed on the pulp to determine the degree of delignification. The last property and important one, that is viscosity of the pulp, is the solution viscosity of a pulp that gives an estimation of the average degree of polymerization of the cellulose fiber. So the pulp which is generated from the digester, the viscosity of it is also very important because it gives that how much polymerization of the cellulose fiber is already happened in the digester. So we already discussed important parameter kappa number. The kappa number, it estimates the amount of chemicals required during the bleaching process of the pulp to obtain the pulp with a degree of whiteness. Since the amount of bleach needed to be added, it is related to the lignin content of the pulp, so the kappa number can be used to monitor the effectiveness of the delignification process or the or the lignin extraction phase of the pulping process. So the kappa number is nothing but monitoring of the delignification process. It is approximately proportional to the how much residual lignin is present in the pulp. If the lignin is more present, kappa number will be more. You will get more kappa number, so it will denote that the color of the pulp is very dark. The downstream processing will depend on that kappa number. If the kappa number is very high, the color of the resulting pulp it tends to very dark, and vice versa. Kappa number can be range of 1 to 100. So we already discussed very briefly about three different kind of pulp varieties, right? So first one is mechanical pulp. One process there is stone ground wood pulp, making of stone ground wood pulp. So in that, mechanically grinding of the wood is being performed into relatively shorter fibers, used mainly in the newsprint and wood containing papers such as lightweight coated and super calendared papers. Next is thermomechanical pulp. The wood particles are softened by steam before entering a pressurized refiner. The end use is to large degree the same as that of the stone ground wood pulp. Semi-chemical pulp, we already discussed there will be chemical operation followed by mechanical operation. So produced in a similar way of thermomechanical pulp, but the wood particles are chemically treated before going to the refiner. And the end use is appropriate for tissue manufacture. Some thermomechanical pulp is used for printing and writing grades. Important one is chemical pulp. One is sulfide pulp and another one is sulfate or craft process, craft pulp. In the sulfide pulp, these are produced by cooking wood chips into a very high pressure vessel in the presence of some bisulfite liquor. These can be bleached or unbleached. Mostly enough white color is being present, so depending on the requirement it can be bleached or it may be like that. Varies from end use can be newspaper, printing and writing papers, tissue and sanitary papers like that. Cracked pulp or sulfate pulp, the pulp produced by cooking the wood chips in a pressure vessel in the presence of sodium hydroxide, NaOH liquor, and it should be bleached before using. There is widespread of its use. Pulp is being used for graphic papers, tissue, uh, carton boards, wrapping, sacks, bags, and any other thing. So uh, these are the main thing you need to take care. So we will be mostly discussing the chemical pulping process. Yeah. So chemical pulping process is by far the dominating pulping method, accounting for 70% of the pulp produced globally. So it is the most dominating pulping method, accounts for 70% of the pulp produced globally. Pulping with chemical process, they aims to damage and dissolve the fiber binding agents consisting of fiber binding agent, those are lignin and pentose like that. So those are being separated from the main cellulosic fiber using some chemical. And this process of damaging and dissolving is called cooking. The process of cooking raw materials with chemical solution is carried out in a reactor which is called digester. During the cooking, the lignin reacts with the chemical solution and forms dissolved compounds, and those are easily washed. Some cellulose also reacts and they produce low pulp yield. If the cellulose also react with the chemicals or the cooking liquors, then it will produce low pulp yield. Chemical pulping can be divided into three types: soda pulping, sulfite pulping, or sulfate pulping. Soda and sulfate processes, they use the alkali chemicals in the cooking liquor or liquids. So composting pulp follows. So they use the alkali chemicals in the cooking liquor. Compared to the mechanical method, chemical process usually produces higher pulp strength and paper quality. That's why we use the most dominatingly we use the chemical pulping process. There is also some industrial process to recover and reuse the chemicals being used and energy more efficiently as much as possible, and the products can be used for making viscose. However, there are several drawbacks that has been questioned from this chemical process because of the lower yield and greater production cost, because lot of chemicals are involved in the overall process. Also, the energy being required in the overall process, so overall the production cost is high, 40 to 50% production cost. Also, there is very unpleasant odor from the chemical from the pulp from this chemical pulping process, and also more pollution to the environment due to the chemicals are being used. There is water pollution. You have seen that there is huge amount of water is being used in pulp and paper industry. So the wastewater being generated in the process, they have dissolved chemicals. So if it is not being treated properly, that may contaminate the environmental water sources. So this is a huge source of water pollution. It is to be taken care very precisely, very carefully. The first process is soda pulping process. In the soda pulping process, the cooking solution used is soda. Pulping, soda means sodium hydroxide, NaOH is used. The soda solution function in the process is for hydrolyzing the lignin and the other fiber binding agents so that the fiber contained in the raw material will be released. There will be reaction that lignin content will be reacting with the NaOH so that there will be release in the lignin from this fiber. Lacking of the cooking chemicals will result in more darker color of the pulp, and there will be difficulty in bleaching in the downstream process. However, excessive cooking chemicals can also reduce the yield of the degradation of cellulose fibers. So, excessive chemical use, you may think that excessive chemical I can use so that there will be more yield of pulp. This is nothing like that. There is always a optimum quantity of chemicals, optimum quantity of the raw material, also the optimum parameters for the digester, this all to be kept in balance so that there will be sufficient yield of or the maximum yield of the degradation of cellulosic fiber. Now this cellulose degradation with concentrated NaOH solution occur at temperature above 1000. If the temperature is too high, amount of degraded carbohydrate or cellulose will be greater than dissolved lignin, which will ultimately reduce the yield of the pulp, and that will reduce the thickness of the pulp. So, temperature, I already told, optimum temperature is to be maintained. Temperature should not be more than 1000, because if it goes more um, far beyond than 1000 degrees Celsius, then the lignin content will be um, more, and that will reduce the yield and thickness of the pulp. It is also easy to recover the NaOH from the liquor, and this is a easy step as it is an advantage from this process. Soda anthraquinone, it is denoted as soda AQ, has also been used to make pulp made of mostly non-woody plants, in which the anthraquinone acts as a redox catalyst, resulting in the increase of yield. Next process is sulfite pulping. So the sulfite process, it produces wood pulp which is almost pure cellulosic fiber. We are using various salts for that, of various salts of sulfurous acid, which used to extract the lignin from the wood chips in the larger pressure vessel, which is called digester. So, in the sulfite process, the salts which are used in the pulping process are either sulfites SO3 2 minus or bisulfites HSO3 minus, depending on the pH of the pulp. The counter ion may be sodium, calcium, potassium, magnesium, and ammonium. The lignin is converted into lignosulfonates, which are soluble and can be separated from cellulosic fibers. Now, this sulfide process involves two types of reactions. Sulfide process involves two types of reactions. First one is hydrolytic splitting of the cellulose, and next followed by reaction of that lignin with bisulfates. Pulping liquor for sulfite pulping process can be calcium based, ammonia based, magnesium based, or sodium based. Alkali you are using. The sulfite process does not degrade lignin to the same extent that it is effective in the Kraft or sulfate process, and the lignosulfonates from the sulfite process are very useful byproducts. So now there will be discussing what is the difference between sulfate and sulfite pulping process. So the thing is, there is lot of difference. We will take one by one. First one is okay. Let me write is as a sulfate pulping, and now here we will discuss about sulfide pulping. So sulfate pulping, we also know this is a Kraft process, right? Whereas sulfite pulping, this is also known as magnified process. Magnified or neutral sulfide process. See, in the sulfate pulping, it is most effective for all kind of um, wood material, soft wood, hard wood, any kind of, and it is effective for bamboo or hardwoods. Okay. Now the thing is, the chemicals used. So okay, I will not do this. Chemical used, number one is in the sulfate process. The main chemical is 60% of NaOH. It also uses 25% of Na2S, and also there is 15% of Na2CO3 aqueous. Whereas in the sulfite process, the chemical used are, if it is magnified process, then there will be this with free SO2, acidic medium. If it is neutral sulfite process, then there will be sodium sulfate, sodium carbonate, like that, even sodium bicarbonate. So these are the chemical used for neutral sulfite process. And acid sulfite, it has sodium bisulfate, sodium sulfate, like that. Next is or mostly the sulfate pulping process. It is done in continuous form, but overall we can say that batch or continuous process we can follow in both of the cases. Okay. Next is this sulfate pulping process. It takes, let's discuss about the parameters. Temperature, it maintains around 170 to 180 degrees Celsius. Pressure, it maintains very high pressure, 10 atmosphere. Whereas in the sulfide process, temperature is lower than that, 120 to 150 degrees Celsius. Pressure is lower than sulfate, that is 4, 4 to 6 atmosphere. Okay. Next is it takes time for digestion, around 5 to 6 minutes, very faster. And for this time of digestion is very longer, like 6 to 10 hours. The types of pulp it is being produced, the pulp quality, it has sulfate, it has brown color pulp, we will see. Um Chlorine dioxide is used for bleaching of pulp, and also unbleached fibers are very strong. Whereas in the sulfide process, we will discuss the pulp quality. So it is off-white color, dull white color, and it is already white in color. So, and it is also easily bleachable. But here the fibers are uh, weaker. And for the sulfate pulping, the material of construction we use mild steel or any alloy which is compatible with caustic liquor, because we are using the caustic liquor as cooking liquor. And for this sulfite, when it is acid um magnified process, so it requires some acid proof lining, acid proof lining inside the digester. So these are some basic difference in the overall process, and the product will be also different. Like in the sulfate process, the products are uh, a strong brown color paper, uh, and subsequent other thing. But here mostly we get the white standard paper, white grades paper. Okay. So moving forward, we will now discuss on the about the sulfate process. Sulfate or craft process. So craft process, it dissolves and removes the lignin matrix from the cellulose fiber, just like other chemical process. In the craft pulp process, the active cooking chemical is white liquor, which consists of NaOH and sodium sulfite, Na2S. A highly alkaline chemical and wood mixture is cooked in a digester under a steam high pressure condition. It is digested. The cooking liquor containing the dissolved lignin and other extractives, and it known as whatever is collected from the bottom end of the digester, that is known as black liquor, and it is then routed to a chemical recovery plant. Very important. Where the lignin and the organic waste are burnt in the in a smelting furnace to produce the energy needed in the pulping process. So that energy is supplied to the pulping plant, and the valuable extractives are separated for sale as commodity chemicals. Brown pulp from the digester is then sent to the bleaching unit and then to the paper making units. Both the softwoods and the hardwoods can be pulped by craft process. It is very effective. Fiber recovery is largely a function of wood species, also the time temperature of the cooking, the degree of bleaching, and the paper strength required. Fiber of recovery, it depends on these parameters. So I will discuss mostly the craft process chemical reactions involved. So first is hydrolysis. Hydrolysis, see in the craft process our main chemical is NaOH. So first is digestion, hydrolysis of, and solubilization of lignin. So what happens? Suppose this is your some kind of biopolymer, and you are using the main caustic soda or NaOH. So you are giving some cellulosic add OH content. Okay. Next, this biopolymer again react with OH. It gives different product as ester. Some cellulosic ester is being formed. So this rate of these reactions are different. That's why you are getting different product. These biopolymer they react with Na2S. How this Na2S is coming, we will see in the next reactions. So they produce mercaptans, and this causes unpleasant smell. Now, in the flow sheet, you will see there is one section that is called smelting furnace smelting process, and another section that is costy sizing process. Two process is very essential to supply the Na2S for digestion of the lignin. So what happens in the smelting process, that you have that lignin salt that is being in the black liquor. It reacts with air, some preheated air you supply, and it will form Na2CO3. Because this R, it this R, it contains carbon, hydrogen, oxygen. Okay, so this carbon will react with oxygen and it forms ultimately Na2CO3 and some CO2 gas. Now another Na2SO4 also react with carbon and they form Na2S. So this Na2S is being used here. Whereas in the causticizing process, this is further taken to causticizing process. Na2CO3, it react with caustic soda CaOH their whole 2 and it produce sodium hydroxide and CaCO3. This CaCO3 further react, it produce calcium hydroxide plus CO2. This CO, it hydrolyzed and it forms CaOH their whole 2. So this CaOH their whole 2, it can be again react with this. It again forms CaCO3 and these reactions are self-dependent, you can say. So ultimately our main product is Na2S we require to produce sufficient quantity by this chemical recovery process so that there will be that can be used in the um, digestion process. Okay, so yeah. So let's discuss the craft process. In the craft process, the first is pre-treatment process of the wood raw material. It should be debugged and cleaned with water and washed and chopped. So reduced size wood chips are being introduced in the chip bins. There is a star valve, so it will take the wood chips to the, because these are solid content, so it will be taken to the deaerator or preheater where will be moisture will be removed. Okay, then it is further taken to the um, lift line, there will be pressure in the lift line. There should be some pressure maintained. So there will be recirculating liquor. That is the black liquor only. There will be recirculated liquor, and this will be faded on the top of the digester. Continuous digesting system is being used. Also in the also in the digester, we are using the white liquor, and sometimes the black liquor modifying stream is being also used to maintain the pressure of this line. Certain pressure conditions is maintained. Okay, we already discussed that pressure is to be maintained at 10 atmospheric pressure. So accordingly, we need to add black liquor into the stream. So when that wood chips and the white and black liquor combination is being fed to the digester, at the top there will be 140 to 150 degrees Celsius. It is maintained by this steam jacket. In the middle there will be 170 to 180 degrees Celsius. It increased. It is also maintained by steam jacket. But at the end, when it will be collecting out of the digester, then it should be maintained at a temperature of 65, because this particular temperature is needed to maintain the strength required for the paper making process. For this strength purpose, it should not cross this temperature so much. So there should be this black liquor, whatever we are getting as a bottom product, yeah, whatever you are getting is bottom product, then it should be recirculated to maintain this temperature of this zone. So ultimately, when it reaches the 65 around temperature, then this digested pulp will be collected to the strainer. From the strainer, there will be maximum separation of the black liquor. Black liquor will be recirculated back wherever it is required. Part of it is required to maintaining the temperature of this zone. Part of it is recirculated back to maintain the pressure of the lift line zone. Okay. So after that, a strainer, it passes through the blow down valve. Blow down valve to avoid the mechanical weakening of the fibers from the steam explosion of the hot liquor when passed through the blow down valve. Then it is pumped back to the blow tank to recover the heat energy. Now the heat energy is recovered, and sometimes this steam form, it is sent back to the maintaining this preheater or in this continuous digester. Wherever it is required, the steam is recirculated. So at the bottom of the blow tank, we will be getting um, a mixture of pulp and other impurities. So it is screened. So undigested residue will be screened out, and the digested one will be sent to the rotary filters. In the rotary filters, there will be separation of solid and liquid. So the liquid product will be, the black liquors will be collected. Okay, and from the black liquor, some of them will be recirculated back to maintain this some conditions in the pulping unit. Other of it will be kept, it will be sent for the chemical recovery, that we will be discussing in the next slide. And the pulp is being produced from the rotary filter. The solid content is sent to the bleaching plant, almost 30%, and 70% pulp is sent to the drying or paper mill. Now, we already see the 30% of produced pulp we sent for the bleaching. So in bleaching, what happens? There will be a removal of the color residue, or the bleaching may be accomplished by use of some bleaching agent. There is various oxidizing agents we use. This agent must be cheap and have minimum degradation action of cellulose. It should not react that much. Traditionally, chlorine type oxidizing agents are used in stage-wise operation. However, bleaching has been found to produce dioxin and other undesirable components of the bleacher effluent. The use of the chlorine as paper mill bleach has steadily been decreased because of this undesirable component more present in the effluent. To substantial extent, chlorine is replaced by hydrogen peroxide. In modern and improved bleaching agent, hydrogen peroxide is added together with NaOH, which activates the peroxide. Then, so a stabilizer is necessary to maintain the peroxide concentration at effective levels, and sodium silicate is mostly commonly used stabilizer agent. Because of bleaching, scales of thin crust are formed on the internal surface of the pulp mill equipment. Such scales of thin crust, especially on the heat transfer surface area, must be removed for periodic investigation or maintaining. It should be removed. So now we will discuss about the chemical recovery. So we have received the black liquor from the pulp plant. Now that from that black liquor, we need to recover the chemicals, and that should be used back to the pulp unit. So in this chemical recovery plant, black liquor that coming from pulp unit that black liquor has 15 to 18% solid. So we need to increase this solid content by removing the moisture in the evaporator system to make it as 48 to 54% solid content, and then subsequently 60 to 65% solid content. This solid content is percentage of solid present in the liquor. Okay, so six effect evaporator system, which is counter current for more effective mass transfer. There will be counter current operation. So black liquor is uh, we are feeding, and there will be steam in the opposite direction. Okay, so this kind of so the ultimate, there will be 48 to 54% solid. It passes through the rotary filter, rotary dryer, and it again dried up to 60 to 65% solid content. It is then this is present, this quadrille precipitator is used to measure the solid content of that stream. Now in the mix tank, there will be mixing of these solids and makeup chemicals. As we are using the craft process, so this is the sulfate, Na2SO4 is used, and extra sulfur is being added. And in the after the mixture tank, then it is fed to the smelter unit or the combustion unit. In the combustion, there will be combustion of the carbonaceous material present in the solid, because we don't need extra moisture content in the as if raw material feeding to the chamber, because that will unnecessary reduce the um, gross calorific value of the raw material of the fuel. So, we have used multiple effect evaporator and rotary dryer to reduce the moisture content as much as possible. Also, we have to use some chemicals to because this role of these chemicals I will be showing by equations that I already discussed before. So this in this combustion chamber, the carbonaceous material will burn, and then it will produce the steam. 28 to 30 atmospheric steam it will produce, and from this the molten slag will be taken to the dissolved tank. There will be extra adding of the cold water, and then that green liquor is being fed to the clarifier. In the clarifier, there will be separation in the um, there will be separation in the liquid and solid further waste slash, and then it will be taken out, and you can see this okay, so this you can see these various streams are used to make use in the dissolved tank. Cold water is used here. From the clarifier upper section, there will be it will be sent to the liming section, where makeup lime or CA, this will be used. There will be some reaction, causticizing tank. From this, the product will be taken to the clarifier, and carbonate mud, or this is nothing but calcium carbonate. This will be taken to the rotary filter and lime kiln. Again, some further processed. So reburnt lime is used in the lime slacker again, reused. So there are basically two unit, combustion chamber and lime slacker. So in the combustion chamber, what is happening? Already discussed that some lignin component will react with air, because we are combusted. It will form Na2CO3 and CO2. Also, we are feeding the chemical Na2SO4 sulfate. This will also react with extra carbons. It will make sure that it produces Na2S and CO2. This Na2S is being fed to the further unit, that is the lime slacker unit, where this Na2CO3 and there will be NaOH. This Na2S, yeah, it is used in the digester, recovered chemical, and NaOH and CaCO3. CaCO3 further react with CaO and CO2. CaO hydrolyzed back to COH. So these are the purpose of these units. Okay. So at the end, I am discussing very briefly the overall craft pulping process. So wood chips, these are first fed into the delignification process. So in the delignification process, cellulose fibers are separated from the lignin in the digester using some chemical mixture Na2S and NaOH. This is called the white liquor. Okay. In the delignification, we are using this white liquor, and after washing, the fibers sent to the bleaching plant. Okay, the fibers are sent to the bleaching plant, drying and pulp. Okay, bleaching plant, we use the chlorine dioxide. Finally, the used delignification liquor, that is called the weak black liquor or like that. So these liquor are separated from the fibers in the washing steps in concentrated in the evaporator to make it heavy black liquor, and then it is sent to the recovery boiler or smelter combustion unit. From there, steam is being produced, and then turbine generator and steam to process it is being used. After that, it is recausticizing again. Spent inorganic chemicals are sent to the and in the smelter there will be a recover boiler. In the smelter there will be Na2, Na, wait. There will be Na2SO4 addition, and then the limes are used, lime clean and this, and then it will be having green liquor that we are getting from the smelter unit. Then it is recausticizing. So in between we are getting green liquor that is being sent to the recausticizing unit, and then again the white liquor is regenerated and then we can use. So this is a complete cycle. Okay, so thank you for this class is up to this. We will be discussing the right. So today's class is up to this much. The paper making process I will cover in the next class, because I don't have time for today, because I can't finish the paper making process within this much of short time. So I will take up this paper making process in the next class, and also we will discuss some other topics left, like environmental issues and other engineering problems associated with this pulp industry. In the next week we will discuss a rest of the part of this pulp and paper industry. So thank you. I hope this video will help you to get more details on pulping process, because I have described um, very other little information that might help you in getting clear idea. So that's all for today. We will meet in the next class. Thank you.